Let me introduce myself. Myself, Abdul Nihal Ahmed. I am working as an assistant professor in GAT Art Science and Commerce College for Women, Malegaon district, Nasik. In this college, I am working as a HOD since from last 10 years, and my total teaching experience is 15 years. So, as far as my topic is concerned, today I will let you know something about plasma polymerization system. So, in the plasma polymerization system, I made ultra thin film and I co-deposited polymer film with the metal particles. So today I will let you know something about how to deposit the film and how to use that film for further characterization. While we are talking about characterization, then we need some of the technique. By using that technique, we can be able to determine, we can be able to identify what is the things present in the film. Okay, now I carried out my practical work as well as theoretical work in the Department of Physics, University of Pune, under the guidance of S.W. Gosavi sir. So today I will let you know what is the content I am going to talk about plasma polymerization system. First, we will see what is the introduction and motivation while we are going to fabricate plasma polymerization system and its co-deposited film. Then later we will see what is the experimental part involved while performing the fabrication of plasma polymerization system. After this, I grow some of the film and we will see what is the characterization technique I used and what are the result and discussions I obtained from my experimental part. And I concluded some of the interesting results we will see in the conclusion part. Okay, let us start with the introduction about plasma polymerization system. Plasma polymerization refers to the formation of polymeric material under the influence of plasma, or in other words, plasma polymerization is used to deposit films are known as plasma polymers. The plasma polymerization can be used to prepare a variety of products like oil, powder, soluble polymer and insoluble film. We are having some of the applications of plasma polymerization system, simple made plasma polymerization system in different fields. Like in optics, we can be able to make reflecting and anti-reflecting coating on different objects. In electronics, we can be able to make ultra thin layer of insulator, packing material, electronic beam resist and X-ray resist material. In electronics packaging, we can be able to make aluminum coated bilayer. Apart from all these, we can be able to make ultra thin film like gold coating on our watch. Let us see the mechanism of plasma polymerization. Plasma polymerization reaction can be categorized into following two groups according to the mechanism of polymer growth. The growth process is divided into two different types. One type is called as the step growth polymerization. Another type is called as the chain growth polymerization. It is also called as the addition polymerization, or it is also called as the addition condensation reaction in the presence of plasma. Now let us start with the first process called as the step growth polymerization. In this process, stepwise repetition of the same reaction over and over again. It means that if the monomer is represented by M, then the growth of molecule by Mi is step growth polymerization can be represented by the following reaction. So one monomer react with the another monomer, it means that we are having two molecules with some water content. Another this resultant M2 plus one monomer gives resultant M3. with some water content. Similarly, the nth monomer, ठीक है, and nth molecule gives the resultant product, and this resultant product is represented by a thin film. The second type is called as a chain growth polymerization. In case of step growth polymerization, the process is very slow, and monomer react with another monomer. It will take a lot of time. So apart from this, if we are going to talk something about chain growth polymerization, then series of constructive step that is completed in a very short time. It means that as compared to previous type of polymerization, this is a very fast process. In this, if M is monomer and M star is chain carrying species, then the chain growth polymerization can be represented by using the following equation. In the following equation, we can be able to see M star plus M. It means that the product or react with the another one gives M2 star, and M2 star react with the another one gives M3 star. Similarly, the mth and nth, and this M, it means that we are going to talk about the final product. Now, apart from this, if we are talking about polymerization and deposition mechanism, then it is having till now we have seen polymerization and types of polymerization. Now we will see polymerization and deposition mechanism by using a simple flow chart. Therefore, the polymerization process is expressed in the following ways. So it requires starting material. Starting material is nothing but monomer, and monomer is nothing but volatile liquid in the form of a liquid. Now, while we are talking about monomer, then we are going to excite. It means that excitation yield. Then that excited or volatile monomer is basically condensed in one of their reactor, and that is nothing but plasma reactor. Therefore, it is named as a reactive species. After this, in the reactive species, there is a growth process in the presence of plasma. It is termed as the yield point 2. And after the growth process, either it is a chain growth or a step growth polymerization, there is a polymer film, and this process is basically called as a polymerization process. Now let us see the fabrication part of plasma polymerization system. Plasma polymerization system is as shown in figure. The reactor for deposition of thin film is nothing but inductive or capacitive coupled gas flow type reactor generates polymerized film. In downstream of gas carrier, gas is nothing but some of the inert gases like argon. A copper plate was used as an external electrode from outside the chamber. Now, in this figure, we will see vacuum. This part is below part is connected to the vacuum pump under a particular pressure. Then the base film, then the reactor. Within the reactor, there is a table that is called as a substrate holder. On this substrate holder, we are having a substance. Above the substance, we are having a metal wire. It is directly connected with the DC power supply, high power supply. And above this, there is a black part, and this black part is basically considered as a capacitively coupled electrode, and it is directly connected to the RF generator. So therefore, this is called as the RF generator plasma polymerized system. In the fabrication part, the most important part of fabrication is nothing but the dimension, each and every dimension of reactor as well as the plasma tube. So here dimension of design of homemade vertical plasma polymerization setup is as shown in figure. In this the prism table the substrate holder is 8 centimeter and the reactor size is 10.5 centimeter, and the length of plasma tube is 22 centimeter and the diameter of plasma tube is 3 centimeter, and the gas flow part is 4.5 centimeter, and here we are having 4 wall, and this 4 wall is basically nothing but in order to insert different monomer we are using this 4 wall, and this wall is having diameter of 1.4 centimeter each. The whole setup is 48 centimeter long, and the vacuum system is directly connected to the 5.6 centimeter hole. Okay. So the live setup, working setup is as shown in figure. It shows RF argon plasma system. Within the reactor we can be able to see the monomer molecule. The monomer molecule is directly going to insert from the tube inside the plasma reactor. Within the reactor, it means that this monomer basically convert into reactive species. It means that from the molecule each and every atom basically separated from each other. As a result, we can be able to say within the reactive species we are having electron, we are having carbon, we are having nitrogen, we are having oxygen, okay, and all the chemical present within the monomer we can be able to expect it within the reactor. So apart from this, if these reactive species react with each other, as a result there is a possibility of formation of bond between them, and if there is a possibility of formation of bond in the presence of plasma, as a result we can be able to expect the polymer film on the surface of the substrate, and we can be able to see by using a step growth process polymer film is deposited on the surface of the substrate. So let us come to the result part. Here I deposited many film, 1 2 3 4 5 film. In this 5 film I have taken the FTIR spectra of plasma polymerized methyl methacrylate at constant pressure of 0.3 torr, constant gas carrier flow 38 cc per minute, constant RF power 40 watt at different mass flow rate. The mass flow rate is nothing but methyl methacrylate flow rate. In methyl methacrylate flow rate, okay, we are going to start from 32 cc per minute, then 35 cc per minute, then 40 cc per minute, 42 cc per minute, 45 cc per minute. So at different flow rate we can be able to observe the drastic change in the chemical composition of deposited thin film. So here we will see as mass flow rate increases, the thickness of the film increases in the presence of plasma, and what are the chemical changes made within the film we can be able to observe from the FTIR spectrum. After FTIR spectra, same film were used for XPS, X-ray photoelectron spectroscopy analysis of plasma polymerized methyl methacrylate film. So here these two spectra basically shows the presence of chemical composition present within the substance. Here we can be able to observe the presence of carbon, presence of oxygen, and presence of other chemical species present within the film at different flow rate. And here we can be able to measure what is the percentage of chemical component present within the substance. It means that within the deposited film. Let us come to the conclusion part. I have made some conclusion. A vertically designed plasma polymerization setup was successfully commenced and used for deposition of PPMMA and PPMMA with the aluminium metal. A system parameter was optimized using composite powder parameter, weight flow meter ratio 0.119 to 0.167. PMMA polymer film and aluminium doped polymer films were characterized using FTIR, XPS and EDAX analysis are as well agreement with the literature value. The simultaneous PMMA with aluminium PMMA shows remarkable change in the fingerprint region, means that 350 to 1500 per centimeter. The EDS spectra shows elemental percentage silicon, oxygen, carbon and aluminium. We can be able to measure up to the 2.4%. Now the XPS analysis shows elemental composition presence of silicon, carbon and oxygen. We could not observe aluminium because it was very less in amount. The presence of single oxygen 1sp are also in good agreement with the reported literature value. The atomic percentage of carbon 1 is and oxygen 1 is depends on the operational parameter. The FWHM of carbon ratio were good agreement with the literature value. Thank you.